Okay, so the idea now is to try to talk about the extended Euclidean algorithm. We already did a video about the Euclidean algorithm. Now we're going to do about the extended Euclidean algorithm, which is basically an Euclidean algorithm that has more results. I mean, you also get the greatest common divisor, but here you also get a combination, linear combination of the two numbers that gives you this greatest common divisor. Let's talk about the extended Euclidean algorithm. So we will find for given a and b integers such that a greater or equal b will get a greater common divisor of a and b, but let's call it, I don't know, c, never mind, but it will be represent as a times b, a times x plus b times y for x and y integers. Okay, so let's start. This will be the idea. How can we find not just the greatest common divisor of two numbers, but also what linear combination of the two numbers that we want to find their greatest common divisor, what linear combinations gives you this greatest common divisor, and it is useful for solving equations like ax plus by equals c. Does this equation for a, b, and c, I don't know, reals and x and y, it's in the dolphin, what something, here it is, Diophantine equations, I think here I have it here. In Diophantine equations for a, b, c integers and x and y is unknown, these equations, if it has a solution, so the greatest common divisor of a and b divide c. This is the condition for this equation with a, b, c integers and x, y unknowns to have a solution. So it is useful here. There it of course useful in cryptography and number theory. For example, greatest common divisor we can see in, I don't want to be not right. We have RC. Wait a second. Okay, never mind. Let's not make something wrong. So the extended Euclidean algorithm, we start with doing the Euclidean algorithm. So you can see it gives you an example for calculating the Euclidean algorithm of two numbers, and I even did a video on it. Of course, if you have another video, go to there, but if you don't, I did a video on the Euclidean algorithm. Now we want to, in this example, to calculate the greatest common divisor of this one, which will be 18, not just to calculate the greatest common divisor, but also show you how this greatest common divisor, which is 18 in this example, can be presented as 252 times unknown x plus 198, this number, times y. And we will find, using the extended Euclidean algorithm, which x and y we need in order to get the greatest common divisor. So we start with doing the Euclidean algorithm. This is the Euclidean algorithm for finding the greatest common divisor of the two numbers. Again, we take A, this is B, this is R, and we are calculating this 198 can be 1 time in 252 with a remainder of 54. We replace this one in here and this one in here, and again calculating this, how many times 54 enter in 198, it's 3 times with remainder of 36, and we are changing it to be here, and we are changing it to be here. A takes B, B takes R, and again, How many times 36 in 54? One time. What remainder? Remainder of 18. Again, taking this r to the b, taking b to the a. Remember that the equation is a equals bq plus r, and every time we are changing a equals b and r and b equals r. We are repeating this until we are getting r equals 0, and then taking and then return b, or you can say return the last r before it became 0. It's the same to say. So here, when r became 0, we can say that we are finished, and the result for GCD of 252 with this number is just this value. The previous r or the current b, whatever you want, this is the GCD of the two numbers. This is the greatest common divisor of the two numbers. Now we want to find what combination of these two numbers can give me the greatest common divisor of the two. So what we are doing is presenting this number here as a combination of other numbers from these equations. So we can take this equation and say that 18 equals 54 minus, take this to this side, right? I can say that 18 equals 54 minus 36 times 1. Now I want to represent this 36 and this 54 using using getting to these numbers. I can represent 36 by this equation with 54 and 98 in this manner. What I did here, eh, I I will push and insert this value, which is just this equation, taking this to this side. I will enter this one instead of this 36. And I did it. And then we get this equation. And now, you understand, we got 36 equals from the second equation from here, 198 minus 54 times 3. Now, plug it in here and get 18 equals 54 minus 198 minus 54 times 3. All of these times 1. We don't need the 1. Okay. Now we can again take this 54 out and get this equals 54 times 4. Wait, times 4, yes, times 4. Minus 198. Now good, we have the 198 inside here, but we have 54. I don't want the 54. I want to represent the greatest common divisor using the original two numbers, the 255 and 198. So what I can do now here, I can use and represent 54 using the original number 198 and 252. So that's what I will do. I will use 40 for the from the first equation. 54 can be represented as 252 minus 198 times 1 if you want. So I can plug this value in here instead and get the thing that you see right over here. So we have 18 equals 54. I can use this. So just 252 minus 198 times 4, which comes from here, and minus 98. Now solve this and get 100, 200 minus 5 times, oh, it's 4 times 200 minus here, from here 4 times, from here 1 time, so it's 5 times 198. Great, so I got this equation, this one. And as you can see here, I represent the greatest common divisor of 252 52 and 198, which is 18. I got it from the Euclidean algorithm here. And I represented it starting from this one. I got to a presentation by the original two numbers. So here, this is my x and this is my y. And I did exactly what I wanted. I did this. I represent the greatest common divisor of two numbers as a linear combination with x and y. This is exactly what I wanted. X is 4 in our case, and y is minus 5 because of the minus here. And this is what the extended Euclidean algorithm does. Starts with the Euclidean algorithm, then presents the greatest common divisor as a linear combination, and take this and take that and represent them as the original numbers on which we did the greatest common divisor function, and represent the greatest common divisor as the linear combination of the two original numbers. This is the extended and you saw the use cases. So this is the extended Euclidean algorithm. Thank you very much. If there are any mistakes or correction or oscillation, please correct me or go watch another video. Thank you very much, and that's it.